Today we'll be taking a look at the involute. Now, in our series of the engineering curves, we have looked at the ellipse, we have looked at the cycloids, the epicycloid, the hypocycloid, and today we'll be doing the involutes. Now, after the involutes in book 1 of technical drawing, the title of the book is Technical Drawing, book 1, Plane and Solid Geometry, right? Now we're doing plane geometry. Isometric, orthographic, those are solid geometry. So right now we're doing all the plane geometric drawings that are in our syllabus. So today we'll be focusing on the involute, but then we'll move on to the Archimedes spiral the next day, then to mechanisms, and then we're finished with this series in engineering drawing, the engineering curves, right? So this is mechanism. Now for this one and this one, we want to focus on the circle and dividing the circle. Now the difference between the involute and the Archimedes spiral is the Archimedes spiral is a fixed point rotating. So you know this is a pole here rotating with a ribbon tied to it. So when the pole is spinning, this is the direction that the ribbon will be following the pole while it is rotating. Or so the pole in the center is rotating, ribbon is attached to the pole, and while the pole rotates, the ribbon follows in this order, and this is called the Archimedes spiral, right? And this is the involute, which is unwinding the circumference of the circle. So the same circle, you keep unwinding it. These straight lines would represent what length the circumference would be at each point. So at 8, it would be this length, from 1 to 8, coming all the way around. Boom. 9, same thing, going all the way around. Now, what we want to do for this now is to get our everything in place. So, look at this. It says the involute of any plane figure is the locus, and the locus is a moving point, and a point and a line rolled round the figure without slipping. So it rolled around, unwinding the circumference like a roll of tape. Just lift up the edge of the tape and wind it around with tension. So you don't just wind it around with just holding it, no, but you hold a little pressure on it or a little tension on it so it doesn't bulge. And this is the shape that you get when you unwind. So you can unwind the circumference of a square or a circle. Here's how we go about doing it. First, it says draw the square. That is for the involute of the square. Draw the square size 25 millimeters. Starting from C, draw radius RE. Starting from C, draw RE, radius. So you draw a line, CX, then open to the radius of CD, which is 25, and scribe, boom. Then when you reach B, you know it'll be 2 times the distance, because it will be CD plus BC. So you times 25 times 2 equal 50. Right, so you open from B, scribe 50 and BY line, boom, get that point. Then you connect the point them with a curve, smooth curve coming around, boom, boom, boom. So if this is R, so CE is R, which is 25, then 2R is 50, then 3R is 150. And that is how you get it. You're basically adding the circumference as you go around. So 25 plus 25 plus 25, because you're unwinding, right? So for this one now, the same thing, but whole thing is not a square, so you can't really add it like that. So you divide this by 12, find out the radius, 2 pi r, 2 pi r, yeah, r, whatever methods of finding out the circumference of the circle, the same length of the circumference, the same length you roll out here, divide the circle into 12, divide this line into 12, then radiate the lines from each point. Now these lines are perpendicular to these lines. So 11, 190-degree angle between 11 and here. So between this one and this one, you have a 90 degrees, which is in this corner. Between 10 and 10, you have a 90 degrees. Between 9 and 9, you have 90 degrees. Look, it's a perfect 90 degrees going straight down. So from all of these points, you go radiate some 90-degree lines, which are perpendicular or tangential to them. Then you open a compass from 0 to 1, scribe on line 1, 0 to 2, scribe on line 2, 0 to 3, scribe on line 3, 0 to 4, scribe on line 4, 0 to 5, scribe on line 5, and so on and so forth. But you don't do this with You don't do this with 0 each time. You do it when you're measuring from 0 to 1, you put that point 1, scribe on line 1. 0 to 2, put that line 2, scribe on line 2. 0 to 3, put that line 3, scribe on line 3. 0 to 4, put that line 4, scribe on line 4. 0 to 5, put that line 5, scribe on line 5. 0 to 7, put that line 7, scribe on line 7. That's how you get that. So let's snip these and put them into AutoCAD and start drawing. SNIP, snipping tool. We want to remove these, have them in our drawing arena, copy. Now we paste them here in our drawing arena. It's very big. Scale it down. Alright, so we can begin drawing now. So we're going to start drawing with construction lines. Now, the first one is this one. And it says that this is 25 according to the book. Like, make sure. So the sides for the square is 25 and the diameter of the circle is 30. Good. So 25, so we get a square that is 25 by 25. Turn on ortho mode so it's straight lines. This gives you only horizontal and vertical lines. If you want angular lines, you create polar tracking. So this one is for different angles. So I'll keep it on 15 degrees here. Straight line, angles, straight line, angles, straight line, angles. Be mindful of that. Alright, the reason why I'm seeing my line so thick is because line weight is on. So I go back to 25, enter, 25, enter, 25, enter. Now the box there now. Now you want to radiate a line art. You can change this to object line. Now I want to radiate my line from A to Z. And it's any random measurement until I draw my. So I radiate all my lines. Boom. And boom. Good. Now from here to here is 25. So the first CE is 25. So I need to mark 25. So what I do is, you can either mark it by drawing another line, or you can use this center, the arc method. Center, start, end. The center. Start at 25. Enter. End. Cut the line. Good. So this one is 50 now, because this side plus this side unwind give you 50. So center, start, end again. Center, start, end. 50. Enter. Boom. And then 150 on this side now, because it's your unwinding the circumference. So R, 2R, 3R. So if R is 25, it's 25 and 25, 50 plus 75. Sorry, I keep on saying 150. But 325 is 75. Thank you for the correction. Yeah, I'm talking to myself though. Here you go, boom. Center, start, end. Boom. This should be 75. Enter. Cut the line. Boom. Then you go ahead and use your spline to draw the involute. SPL. And see how this one easy. This one's like baby. PL. Enter. Boom. 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 Wow, this ugly bad man. Jaja. Anyways, let me get to. But let me get. Stress me out. The ugly bad man. No, sir. The ugly bad man. Do it again. SPL. Enter. No, sir. Do it again. Do the right thing. SPL. Enter. Anything you look like, Boom. 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 Change these to phantom or section or phantom. Alright. And then this is object line. And these are construction lines. And then basically you just do labeling now. That is the involute of a square. Right? You just basically finish lettering and labeling, and that's it for that one. And put in your title. Then you also want to have this constructing an involute given the whatever it is in the book. So construct involute of a square. So constructing the involute of a square and constructing the involute of a circle. Good. Now for the one with the circle. And I don't want just to hover over this enough. I'm serious. When you're submitting a work, you must look properly labeled and properly completed all the time. Every single time. Good. So the next one, the circle is 30 in diameter according to the book. So we draw a circle. First, center lines. Boom. Boom. Turn on ortho so you have straight lines. Orthographic mode. Ortho mode. Boom. Boom. And then radius is 15. Enter. Boom. Now what you want to do now is divide this circle into 12. So divide 12. You divide it into 12. Go ahead and connect all your points. Alright, so after you do all that now, basically want to project your line this way. So you basically want to project that line that way. Boom. After you project that line, next thing you want to do is you want to divide this line into 12 also, but you want the length of this line to be the same as the circumference of the circle, right? So you find out what the circumference of the circle is. Right click, properties, quick properties. Circumference is 94.2. So you want to draw the line to be exactly 94.2. From there, 94.2. Enter. Right, so that is the circumference rolled out. You want to divide that into 12 equal divisions. Right? So 12, enter, boom. Right, very good. Now, next thing you want to do after this is to radiate your lines. Right? The only reason you needed to divide this into 12 is because you needed to match the measurement each time. So from here to here, going out, from here to here, going out, right? So what I'm going to do now is, when you have a compass, you would put your compass point at 0, open to 2, then put the compass point at 2 and scribe on line 2. That is radiating, right? Put your compass point from 0 to 11, open your compass to 0 to 11, put it at point 11 and scribe on line 11. And that's how you get these points that you can connect them going all the way around. However, because we're not using a compass, we may not need to do all that. We just need to know what the measurement of here to here is, then use offset, and then offset from here to there. That'll show you how I get that done. So AutoCAD is very versatile, so as I always mention to you, you can use any method which works best for you. So here's what I'm going to do now, is radiate my lines, my angular lines. So you turn on object snap, not polar tracking I mean. Ensure that you're on 30 degrees angular angles that can snap there. So I'll use 30 for this one. And go ahead like that. So 90 degrees that way. Boom. 90 degrees that way. 90 degrees that way. 90 degrees that way. So it can make life easier. When you're doing this in manual drawing, a lot of my students usually have great problems trying to figure this one out in manual drawing. But in order to get it, because of polar tracking, life becomes much easier. As a matter of fact, when you know how to use the software, you're basically learning a life skill. So anything you need to draw, you can always use the software to produce those drawings, especially if other software would permit you to draw that particular item. Extending my line just a little bit more. Right, so I already did all my lines. Next thing I want to do is to plot them. So how I go about doing this now is to offset, the versatile function called offset. So I want to use lines that I can delete later. So some phantom lines, and I go ahead and draw them in, right? And I go draw them on all of my lines. Why? Because I'm going to offset this to the measurement of from 1 to whatever it is. So draw some lines. I mean, there are other ways you can do it. So whichever way works for you, it's okay. Because as I said before, the software is versatile. So it doesn't only give you one way to do any single thing. If you find a way to get the procedures done and to get it done accurately, fine by me. I won't try to keep you confined to any particular process. Because we're living in a dynamic world. To function in this world, you can't be static. You have to keep moving, keep learning, keep improving, keep getting better every day. Alright, now, so we need a measurement from 0 to 1, right? So what we do is go to line 1, offset this distance, right? So offset, click. It says through, so you want this distance through this distance, and then click this line. Boom. See that? So we use the through method for offsetting. Usually you type in a measurement when you're doing offset, like notice the specified distance come up as 7.8, but no, that's not what we want, because 7.8 is the distance from here to here, right? But we want from here to 2, because the line 2 we are doing for now. So you measure from here through to here, and then click this one from here to here, and we get the measurement. Now if we do it again, so enter again to repeat the command. It says specify offset distance. You want to do from 0 to 3, because line 3 I got to know. So 0 to 3, and click from line 3 down here, going up, right? And that's how, notice how it keeps progressing in a uniform manner. That's right. So that's why we had these lines in the first place. So yes, so to line 3 now, so line 4 after. So enter, start, 1, 2, 3, 4, there, and then line 4. Now we'll do the same thing again, enter, repeat command. You can use spacebar or enter to repeat the last command. So 1, 2, 3, 4, 5, there, 1, 2, 3, 4, 5, here. Alright. Now the next thing I want to do, you have to ensure that these extra lines to draw are in line with these, so that means they meet perfectly on here. Alright, so the next thing we want to do is same thing, repeat command, offset through 0 to 1, 2, 3, 4, 5, 6, 0 to 6. Then come to 6, offset. Next step, offset again. 1, 0 to 1, 2, 3, 4, 5, 6, 7, 0 to 7. And offset. Again, enter, 0 to 8. So 1, 2, 3, 4, 5, 6, 7, 8. 0 to 8. And enter. right? And then we go 0 to 9 now. 0 to 9 is, if you are finding it confusing, you can letter and label your drawings as you go along. But I always finish before letter because I understand what I'm doing. But if you need to letter, you letter. Or you can look at the diagram that you're drawing from. So 9 is the one to come straight down, then 10 after 9, right? So select offset from 0 through to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom. So 10 here, offset. And then the last one, which is 11 there. So offset again from 0 to 11 and step off 11. Now 12 is right at the end of the line. So now we can draw in our involute. So change it to for object line and draw spline line. SPL, enter. From 0 to 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8. Where 9 there? Jaja. To 9. So we'll fix that. To 10 to 11 to 12. Alright, so something wrong here, so I'm gonna go back and check again. We're not perfect, you know, so we make mistakes. So measure 9 again, so offset from center to 1, 2, 3, 4, 5, 6, 7, 8, 9. Boom. And then offset from the 9 downwards. And here. So this point should be here. And move it back to 9. Good. And then do 10 again, just to make sure everything is in sync. So measure from 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom. Offset 10. It's right. So 11 seems. I'll do 11 again just to make sure. Offset 11. The last one. 11 is correct also. And 12. Right. And here you go. Here you have it. The involute of a square, involute of a circle. It's almost perfect. In drawing, you would have to use your freehand or your French curve or flexi curve to form the involute, and this would be a challenge for most persons. But there you have it. Right. So now what you can do is trim the excess lines and do your labeling afterwards. So trim, DR, enter, trim, 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 DR, enter, trim, 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 trim. And then that's you, that's you, that's you, that's you. So there's the labeling now. All the lettering, the labeling. If the letters are too big to fit in here, scale them down to a smaller size. Put them inside here. Do your labeling for your circumference. Do all your labeling. And that's you.